Madison, are you okay with that?
Yeah.
Okay. What would we want to do next? Okay, so when you say times, you don't really mean multiply. What you mean is we're going to do the exponent of 3/5 to both sides. So multiplication and exponent are not really the same operation, so we have to be a little bit careful there. Yeah, so when I have an exponent of an exponent, I do multiplication. That is correct. So the 3/5 to both sides is going to cancel the 5/3 exponent. And then if I type into my calculator 243 to the 3/5, I get 27. Now, should this be a plus or minus here? No, why not? Yeah, if I look, the root that I did to both sides was an odd root, and odd roots do not result in a plus or minus. So I just have x minus 5 equals 27. And to finish this, then we would add 5 to both sides to get 32. Do I need to check this answer? No, I don't need to check the answer because the original problem is not an even root. Is not an even root. If it was, because look at the original problem, it's a cube root, right? It's an odd root. We don't need to check the odd root problems. We can't get extraneous solutions for those. Does that feel better, Madison? Okay. Harley? 7? Okay. What did you want to do first here? Okay, I agree. Okay, and then what? Right, dividing by negative 1/4 is the same as multiplying by negative 4. So I'm just going to write it that way. It's a little bit cleaner looking that way. So there's that. Okay. And then what do we want to do? Cube both sides. So the cube is going to cancel the cube root. And then if I do negative 48 to the third, I get 110,553 or 592, excuse me. Everybody okay there? Okay, now what? Not add, subtract, right? So that's going to give me negative 110,602. And then my last step would then to be, and which is the same thing as multiplying by 4/3, which is how I'm going to think about it. So I do just that number. Oops. Forgot to subtract the 10. And then we got to multiply it by 4/3. So I get x equals negative 147,469.3 repeating. Or if you wanted to, you could have represented that decimal as a fraction. Nope, I guess not. It didn't want to give me a fraction out of it. What a booger. Harley, are you okay with that?
Yeah.
So did I.
I thought I got the wrong answer. It was such a small.
Yeah, it did not work out nearly as conveniently as most of the other ones did. But, yep, that's the answer there. Others? Anyone else want to talk about these? Henry.
Number 6.
Okay. So what do you want to do first here for number 6? Oh, FYI. Sorry about number 7 here real quick. You'd also need to check that. I'm going to just tell you that it checks out. But because oh, no, you don't need to check this. The original problem was a cube root. I lied. That's done. Sorry. No, nothing to go back on. Looking at number 6. What would I want to do first?
Yeah, 6.
Agreed? Oops. Okay, so we added 6. Then what?
Would I multiply by 4?
How about dividing by -4?
No.
Does that work for you? Now, on my work here, I stopped. Why did I stop at this point? Henry?
Is it because it equals a negative?
Yeah, so a square root can't give you a negative number. So I knew right away that this was going to have no solution to it. But let's pretend we didn't notice that and keep on going. Because probably a lot of us would have gotten to this point and just kept going, right? That's fine. So what would I do next?
Sum it to 5.
Nope, we got to get rid of that square root first before we can get to the 5s. So,
Multiply by 2.
yeah, we'll square both sides. So squaring is different than multiplying by 2, just to make sure that we're clear on that. Because -4 squared is 16. And then we can subtract the 5 and divide by 2, right? Is that okay there? So I get x equals 11 over 2. But I still need to check this. So to check this, what I'm going to do is I'm going to go back to the original problem, and I'm going to plug 11 over 2 in for x and see if the left-hand side gives me 10, right? So let's see what happens. -2 times the square root of 2 times 11 over 2 plus 5, and then minus 6. Look at what I got. -22. That ain't 10. So I'm going to discard this solution. This is an extraneous solution. And since I have discarded my only solution, what would I write? No solution, because I have no solutions left. Is that okay, Henry?
Yeah.
Okay. Last call from this paper. Anyone else with last minute questions? Okie dokie. We're going to continue on today. We're going to continue talking about solving. So the problems we're going to look at today are a little bit more complicated than the problems that we looked at yesterday. So the first example I'm going to look at is x plus 1 equals the square root of 7x plus 15. What do you notice is fundamentally different about this problem than the problems we worked on in last night's homework? Caden? Yeah, so we have x's in two locations, right? So that's the big difference here, and you're going to see that that is going to add a fair bit of complexity to this problem when I have x's in more than one location. So the first thing that I'd want to do is try to isolate the radical. In this problem, that's already been done for us because the radical's by itself, right? Everybody okay with that idea? One side of the equation is just a radical, and all the other stuff is on the other side. Once the radical's been isolated, the next thing I'm going to do is cancel out the radical. So what would I have to do to both sides to cancel this particular radical? Yeah, we're going to use a square, so we're going to square both sides, use the exponent of 2. So that'll cancel out the square root, leaving you with 7x plus 15 on the right-hand side. What do I get when I do x plus 1 squared? X squared plus 1 is absolutely incorrect. So remember yesterday we talked about this freshman's formula that's never true. That's what you just used to get x squared plus 1. Definitely don't want to do that. What does that mean? X plus 1 with a parenthesis around it and then the squared on the outside? Yeah, it means x plus 1 times x plus 1. So what are we really going to have to do there? We're going to have to FOIL. So when I do that, I get x squared plus x plus 1. Is everybody okay there? Okay. So I notice I can combine some like terms. So I can do x plus x to give me 2x. And what kind of an equation do I have now? This is some quadratic, right? We've studied these a lot first semester. What do I need to do to solve a quadratic equation? Well, before I can do any of those things, what has to happen? What does it have to equal? It has to equal 0. So let's start here by subtracting 7x and 15 from both sides. To get it equal to 0. Everybody happy there? Now, to solve a quadratic equation that's equal to 0, we have 3 options. The quadratic formula is one of those options. Does anybody remember what the other 2 options were? Factoring is a second. And the third one is if there's only x squareds, you can solve it directly, right? Which one do you want to do for this problem? Can I solve this one directly? No. So we're down to factoring or the quadratic formula. Is this one factorable? Are there 2 numbers that multiply to give me negative 14 and then add to give me negative 5? Yeah, there are. So let's factor it. What are the 2 numbers that do that? close, one of them has to be negative to get the negative 14. Good. So I'll be x minus 7 and x plus 2. We okay there? So to solve that, then I can just set each of those factors equal to 0 and solve them separately. So that gives me 7 and negative 2. Am I finished here? No. What do I still need to do? Starts with a C. I got to check. Got to check. Why do I need to check this problem? It was an even root, right? There's a square root in the beginning. So to check this, what I'm going to do is I'm going to look at the original problem, and I'm going to plug 7 into the left-hand side. So when I do that, I get 7 plus 1, which gives me 8. And then I'm also going to plug 7 into the right-hand side. When I do that, I get 7 times 7 plus 15, which also gives me 8. So 7 is an answer. Everybody's good with that? I'm going to do the same thing now with negative 2. Negative 2 plus 1 is negative 1. And already I know that that's not going to work. But I'll continue and do the other side as well, just to kind of illustrate. Oops. And 7 times negative 2 plus 15 gives me positive 1. Notice that those two didn't agree. So I know negative 2 is not one of our actual solutions. So I'm going to cross that one out and just box up 7. And I'm going to put a check mark next to it to remind myself that I checked that. Is everybody okay there? Let's do another of these, shall we? So what if we do 10x plus 9 equals x plus 3? It's the first thing I should do. Yeah, let's square both sides to cancel out the radical. So that's going to give me the 10x plus 9. And then what do I do for x plus 3 squared? Yeah, I'm going to have to FOIL, so I'll write that as x plus 3 times x plus 3. So when I FOIL this out, I get x squared plus 3x plus 3x plus 9. And if I combine those like terms, I get x squared plus 6x plus 9. Okay. Now that everything's all FOILed out, what do I do next? Yeah, it's got to get equal to 0. So I'm going to subtract 10x from both sides and 9 from both sides. Usually I try to keep the x squared positive because it makes it easier to factor if I do that, just as an FYI. So when I do that, I get x squared equals x squared minus 4x. Everybody's cool so far? So here's my quadratic equation. How am I going to solve this? Remember, there's 3 ways. I could either Use the quadratic formula. I could factor, or I can solve directly. Is directly an option in this case? No, because I have both x's and x squareds. So we should either factor or use the quadratic formula. Is this factorable? Definitely is, yeah. In fact, it's the easiest kind of factoring. Since there's only two terms, I can just look for a greatest common factor here, right? Is there anything in common between x squared and negative 4x? X. So I can just factor an x out. And now when I take each of these two factors and set them equal to 0, I get x equals 0 and x equals 4. Everybody good to hear? Am I finished?
No.
No. Gotta check. So I go back to the original problem, and I'll just do this on my calculator. So I'll check the left hand or the right hand side. Yeah, the left hand side. Excuse me. Sheepers creepers. Left and right is hard, guys. And then I'll check the right hand side, also with 0. And I saw that that works. So 0 is an answer. Now we'll do the same thing with 4. And that also worked, right? So both of those are answers. Are we okay with this kind of a problem? Okay. Let's look at another kind that is similar, but not identical. So if I take a, yes, Nina? Sure. So take a look at this problem. How is this different than the previous problem? Yeah, there's two x's still, but this time they're both under square roots, right? Okay. What am I going to do first in this situation? I would square both sides. And that's nice because the squares are just going to cancel the square roots. And what I'm left with is like a super easy problem, right? So we'll just subtract x from both sides and then subtract 5 from both sides to give us x equals 2. Am I done? Good. Since it's an even root, we still need to check. So 2 times 2 plus 5. And then, oops, 2 plus 7. Since both of those gave me 3, I know that works, and we're done. So this is the easiest situation, right, when we have x's both under radicals. Oh, I will. Let's look at one more, or one more situation anyways. How is this situation different than the previous one? Yeah, we have this extra stuff going on outside of the radical. Is that going to make a big difference? It actually makes a kind of a super big difference, surprisingly. What do you think we want to do to start? Square both sides. Okay. So on the right-hand side, the square can just cancel the square root. And we're left with 3 minus x. What do I have to do on the left-hand side, though? Can I just write that as x plus 2 plus 1 squared? We have to FOIL here. Why are we having to FOIL on this problem as opposed to the previous problem? Because we have this stupid addition symbol going on outside of the radical. Caden. So you can't do something to just part of a side. If you're applying an exponent, you have to do it to the whole side or not at all. So for example here, let's just do a situation with numbers. Like 1 plus 4 is equal to 5, right? For this to remain true, I can't just square this part and this part, right? That's nonsense. I have to square the whole thing for that to still remain equal, right? That's what's going on here. Does that make sense when I do just numbers and get rid of all the variables? And that's a good way to kind of check on your own, right? Like, I wonder if it's okay if I do this. Write something out with just numbers involved and see if, like, are the two sides still equal after I do what I'm thinking I'm going to do? And usually that'll be a nice quick indicator of whether what you're doing is okay or not. Okay? All right, so let's FOIL this out. So these guys will multiply together. That's the firsts. And then my outer, my inner, and then my last. Is everybody okay with how I FOILed that out? Okay, so we can simplify things here a little bit now. The square root of x plus 2 squared, well, the square is just going to cancel the square root. That leaves me with just an x plus 2. These guys are identical radicals, right? So I can add them together by adding their coefficients. So that's going to give me 2 square root x plus 2. And then I still have that plus 1 there at the end. So far, so good? Let's combine our like terms. I have a plus 2 and a plus 1. I can turn that into a plus 3. And now what I'm going to do is this problem looks a little bit like that very first example we gave, where I have x's inside the radical and x's outside the radical, right? So I'm going to solve it kind of the same way. I'm going to start by isolating the radical. So I'm going to subtract x from both sides, and then subtract 3 from both sides. Everybody okay there? What should I do next? I don't know what that means. I would do one thing before I do that. Yeah, let's get that 2 out of there. So we'll divide both sides by 2. And now, as Caden suggested, we can square both sides. So the square root of x plus 2 squared, the square cancels the square root. So we're left with just x plus 2. And negative x squared is negative x times negative x, which is positive x squared. So I'm left with this quadratic equation. How do I solve this quadratic equation? Got to be equal to 0. So I'm going to subtract x and then subtract 2 from both sides. And then how do you want to solve x, or 0 equals x squared minus x minus 2? Let's try to factor that. What are the two numbers that multiply to give us negative 2 and add to give us negative 1? Negative 2 and positive 1, right? So I'll set those factors equal to 0 and solve, giving me x equals 2 and x equals negative 1. Am I done? No. What do I still need to do? Jeepers creepers, I still got to check. All right. So where do I check at? Have to check at the very beginning. So I'll use x equals 2 first. So the left-hand side gives me 3. And the right-hand side gives me 1. Those did not agree. So I'm going to discard that solution. Now let's try the negative 1. So that gives me 2. And when I try the right-hand side, that also gives me 2. So the only solution I have left is negative 1. Everybody okay there? So in general, kind of the outline for this problem is I start with something that looks like this. A radical plus a constant equals another radical. I squared both sides to get something where I can get a radical equals x plus some constant. And then I squared both sides to get a quadratic. And then I solved the quadratic to get my answer. So that's kind of the path that I use to solve those problems. Let's do one more example like that, and then we'll be finished for today. Sound good? Okay. I'm going to lean on you guys to tell me what to do this time, though, so get ready to give some instructions. This last example is the square root of x plus 6 minus 2 equals the square root of x minus 2. What should I do first? Square both sides. Okay. On the left-hand side, what do I have to do? Great. So we're going to have to FOIL on the left-hand side. So let's write it out like a FOIL problem. And on the right-hand side, what are we going to do? Yeah, the squared cancels the square root, and we're left with just x minus 2. Everybody good here? What do I do next? So square root of x plus 6 times the square root of x plus 6 gives me just an x plus 6. Is that what you wanted to write? I couldn't hear.
Yeah.
That's okay? Okay. Everybody sees why that's giving me just an x plus 6? Okay. As long as we see. We haven't done anything with it yet. We've just multiplied the firsts. So then we do this one. Right? And then we do the inners. And then we do the lasts. Is everybody happy with what we did there? You see the foiling happening? Okay, what should I do next? Combine the like terms, great. So what can I combine? Okay, the 6 and 4 give me a 10, and then the two radicals give me minus 4 root x plus 6. Cool. Now what? I'm sorry, what did you say, Madison? So when I have identical radicals, like I do here, I can combine them by adding the coefficients. Right? We did a homework assignment a couple days ago concerning this. Does that start to jog your memory now? Let's get the radical by itself. So I don't want to add the 2. I'd want to go the other way, subtracting the 10. Is that okay, Madison? And we also should subtract the x. Look at what's happened here. No, but look at what we lost. We have only one x left, right? We have just the x underneath the radical. The x outside the radical kind of canceled out. That's very nice because you know what's just happened? Instead of this turning into a problem like we had at the very beginning of the lesson, this has turned into a problem like we had yesterday's homework, which is much, much faster to solve, right? Because we won't have a quadratic. That's pretty righteous. All right, continuing on. Well, we don't have the square root by itself, right? So what should we do next? Yeah, divide by the negative 4. And now when the square root is all by itself, it is equal to a positive, and everything is fine, right? You see the distinction there, Caden? So until the square root is by itself, you can't say beans about whether it's negative or not. Okay. Now what? Do what? Yeah, you're going to square both sides again, right? To get rid of the square root. So what does that leave me when I square both sides? X plus 6 equals 9, giving me x equals 3. Am I finished? Gotta check. But at least I only have one number to check, right? All right, so we have 3, or square root 3 plus 6 minus 2. That gives me 1. And then square root 3 minus 2. That also gives me 1. So this answer works, and I'm finished. We'll stop.